So today I'm going to talk a little bit about content acceleration beyond caching, the more difficult parts of a CDN. I'm going to go over some challenges. Some of these are going to be review slides, so the first couple slides are going to be a little bit of review, and then we'll get into the heart of the presentation. We'll also go over some replication strategies for dynamic content. We'll visualize what the CDN is doing, and finally go over some best practices. So the internet is a network of networks, right? It's global ISPs connected to regional ISPs, and content is traversing generally multiple ISPs to get from source to destination. And because of this and the long distance, you've got a couple of issues that affect performance, and especially global performance. The first being distance. The further you are away from content, the longer it takes to get there. I mean, you're constrained by speed of light and also routers and all the hops along the way slow things down. In addition, the internet being congested, packet loss happens, retransmission happens. Generally, this is not a problem. The protocols, TCP, and the browsers take care of any necessary retransmission, but it does cause slowness in the process. And then third is that TCP, which is what HTTP is based on, is inefficient, and it's a chatty protocol. It's got a slow start. It goes back and forth to set up the connection. Then the data comes down, and then the connection is closed down. So all of those together represent a lot of challenges with global performance. Here's a representation of what you might see. This happens to be a 24K object from the east coast of the United States, and as it pushes out to Midwest and West Coast and across the ocean, you can see the distance gets greater and greater, and it's multiple times slower for the content to happen. The one in the far right is Beijing, and anything that's behind the Great Firewall of China also has some extra milliseconds differences, but all of it constrained together poses challenges for getting content quickly to end users. And of course, web pages themselves, they don't help. Everybody expects really personalized web pages. They expect data to be as real-time as possible. And the content owners are striving to do this as well. The pages themselves, I read webperformancetoday.com, and so personalized content, and then I think I was talking about the Web Performance Today blog. I like reading her blog site, and she talks about some of the obvious things. You know, web pages themselves are getting richer and richer and more content. I was surprised to see that e-commerce sites are taking longer and longer to load, even just in the past couple years. I'm not quite sure why we would find that acceptable. And with the e-commerce themselves and customers really fast switching to secure content, HTTPS content, there's a lot of SSL, TLS negotiation that's going on, and that's slowing things down as well. And one last thing to mention on the things that are slowing down global performance are external links. So most websites have a bunch of external links from all your partners collecting metrics and things like that. In the worst case scenario, like in China and some other countries, some of these sites are going to be, or domains are going to be blocked. And in kind of a best case, you need to make sure that the target for your global audience matches. So your third parties match what your site is trying to achieve in terms of performance, and make sure that there's not a disconnect there. Otherwise, you'll get blocking. So I think this is my last review slide just to get everybody on the same page for some terminology. There's two types of content that I'm going to talk about: static content, dynamic content. Static content is when we all log into a web page and we basically see the same thing. It's the Twitter logo, the HTML, some CSS, something like that. That's all static. We all see the same thing. Dynamic content is that personalized real-time content. When we log in, pretty much everybody in the room is going to see something different in that. And there are different techniques that I'm going to talk about for acceleration that cover these two types of content. So static content, if you haven't looked at it before, HTTP has host headers, and you can take a look at what's going on there. Static content will usually have something like a cache control header. We'll say something like a max age of X number of seconds. And what happens is the web browser and any proxy servers and CDNs and all of them, they just honor the rules. They follow what is instructed here in the header. So that's pretty straightforward. I think probably most everybody's used to setting up static content and putting a time to live, and then there's a bunch of algorithms that CDNs and other proxy servers use to make sure that they keep it up to date and don't waste extra bandwidth. Dynamic content, somewhat surprising maybe, is very similar. I mean, there's probably a cache control header in your dynamic content as well. It's just set to max age of 0, no cache. And again, it's a policy. You have to follow the rules for the browser and the proxy servers and the CDNs to not cache that content. So static, set your TTLs. Dynamic content, just to clarify two other wording choices here, the difference between dynamic acceleration and whole site delivery. So when I talk about dynamic acceleration in this presentation, I'm going to mean where the CDN, or let's say a WAN acceleration vendor, is actively doing something to improve their performance in the first mile, in the middle mile, and the last mile, as opposed to somebody who might call something whole site delivery, which is more of just a relay. In other words, it handles static traffic in the standard way, but dynamic traffic just gets passed through, so there's no acceleration there. So just keep in mind, I'm talking about the difference between a path that has acceleration on it and a path that is just being passed through. And then third, a little bit later, I'm going to talk about encrypted content. Some CDNs can accept encrypted content more at the network layer and accelerate that along the way using a multitude of techniques, and we'll go through those different techniques. So static caching is pretty easy. I would have to guess that almost everybody here is using a CDN or something like that to do caching. There's everything from from free to tier 1 enterprise CDNs. You set the TTL, as I've mentioned before. CDNs will honor that, and if a mistake was made, you just ask the CDN to get rid of that content. So it's pretty straightforward. That's just kind of a summary of static and kind of the way that we all handle it today. Here's a representation of what is actually happening, and I really kind of use this to build on the dynamic parts of the presentation. So this is pretty straightforward. I talked early on about if you're close to content, you're going to be faster, and this represents that you're faster, and you can see how it goes. So it'll get more exciting with the dynamic content. In this slide, I'm just adding compression to it. Not so much to say that this slide is worth looking at because it's got compression, but I want to point out that CDNs and other hardware vendors and the like, we all add these techniques to each other and build them all up. So you start with compression, you add caching, you add this, you add that. We're going to talk about dynamic. So just keep in mind that these things are cumulative. So dynamic is a little bit harder because it's personalized and because it's sometimes real time. You have to think differently about your consistency requirements for that type of data, and then make sure you design your architecture to support it. So I've got a few slides here. I'm going to go into consistency and talk about what needs to happen if you want to replicate that real-time personalized data. So a couple of questions just to think about. How many hits did I get on my web page? Well, if you got 4,100,000 versus 4,200,000, I'm not sure it makes a difference. Close enough might be okay for that kind of data versus how many people viewed my LinkedIn profile. Maybe I'm paying for that as a pro account and I do want to know, but if it's updated daily or hourly or something, it's probably okay. What if I want to buy seat 11B on an airline? Well, you pretty much only want to sell that one time, and airlines have enough problems. They don't need to be selling the same seat multiple times. So there's three approaches that you look at when you're doing consistency for this type of data. You've got weak and eventual and strong consistency. Weak consistency is best effort. Generally, it's acceptable for some data loss, like I talked about that web page counter, or even something that seems different, like VoIP or UDP streaming, right? You can drop some packets, and it's not a problem. Eventual consistency, I tend to think of as something you put into a work queue. It eventually gets there. If you write something and then do a read for multiple locations, you won't necessarily always get the data immediately, but if you wait that hour or however long you've architected your system for, you'll get the data. And then third is strong consistency, where you think of something like database transactions, where you're waiting for confirmation that everything worked, where you're selling seat 11B just one time. But data centers come into play in terms of this. If you've got a single data center, it's probably pretty easy to do any of them, weak, eventual, strong. You can get redundant power, you can get redundant ISPs, you can get redundant network equipment, you can cross-connect everything. You can make something pretty reliable in a single data center. Of course, if you've been in the data center space any length of time, you kind of expect that they go down, and you watch cloud vendors and they kind of go down. If you want to do multiple data centers, weak and eventual consistency, really it's still not that much harder. It's a little bit harder to think about the architecture and design your recovery windows and things like that, but it's pretty straightforward. The issue becomes when you want strong consistency, and that's much more difficult if you're thinking of something like a bank transaction, or you can sell things only one time. It's just multiple times harder to do. And I'm not going to go into a banking transaction, but I did want to show just some of the things that can fail just to keep it in mind. So if you've got a client talking to a coordinator, you might want to withdraw from a bank and withdraw and deposit, and all of these are supposed to be in a transaction, and any or all of these things can fail. It's rather difficult to do. So what do people choose to do when they're thinking about dynamic replication? And really, you know, my presentation's on performance and availability, and you need to have some replication strategy for the best availability percentages. Well, one is just don't do it, as I kind of mentioned. Build the single best data center you can for your solution and go with that. Know that there could be some downtime. Plan your recovery windows, plan your customer notifications, keep everybody up to date, and go with that. The other, a good solution, is a master replica or multi-master solution. I generally don't consider that to be strong consistency, though some of the terms vary. You might lose some data loss. You might have a much harder recovery window and backup strategies, but still can be done. And then third would be something much more complex, where you've got 2 or 3-phase commit using Paxos, where you're thinking of like the banking scenario or Seat 11B. So once you get the availability point of view, deciding your consistency requirements, deciding what you're going to have happen if an origin fails over and you've got this dynamic content, what about performance? Well, here's just a representation, and I'll show you in more details what I'm talking about, but here's a representation of 2 or 3 data centers in the middle, and then what a global CDN is able to do. So even if you've got your replication strategy for availability, you still generally have to have some solution, some strategy, some plan for the performance side of the house. All right, we're going to go into a little bit of some animated slides on CDN techniques. These are just common techniques I'm going to share. Different CDNs will use different techniques. Different WAN acceleration vendors will use different techniques. Most CDNs don't specifically say exactly what they're doing. A lot of them are really software-based, and some of this is adaptive, and the techniques can kind of come and go based on it. I would say, bottom line, though, performance, end-user performance is what matters, and you can measure that. And we'll jump into the techniques, but I'm not sure it's worth trying to note down every single technique that's there. So it's a little bit of background on TCP. Anybody's heard of Velocity Session? I'm sure a lot of talk has been done on TCP. And here's a slide from Asperasoft that I kind of liked. It shows round trip time and packet loss. When TCP is working good, you're in the far backhand corner of this chart, it's working really good. But as soon as that round trip time or the packet loss comes in, it starts to degrade quickly. Here's another representation that ESJ did, and it kind of puts it in a different path. The far left bar there is Chicago to Houston. So if you're Midwest to Midwest, you got some great throughput, great performance. You can do a whole bunch of things. Once you start to go east-west US, starts to drop down dramatically. And then once you jump over an ocean, just a disaster in terms of the throughput that's available. So CDNs and hardware vendors, we're aware of that. We're looking at that drop-off and that curve and trying as best as possible to keep the network traffic in that far backhand yellow-orange colored bar that was there. So we are looking at that and trying to get the highest throughput by maximizing all of these different techniques. Here's an example of, we talked about the growing nature of secure content. And so there's a lot of negotiation that happens with SSL, TLS, HTTP as content. And it uses a technique that's somewhat similar to caching in the sense that it moves things closer. A CDN can host a certificate on the edge and speed things up. And that's for the negotiation and the connection-oriented part. But if you've got, once you get to the data, there's other techniques that come into play. So for example, a CDN will have, I talked about a first mile and a middle mile and a last mile. CDNs can do connection pooling and keep alive, where they will keep a connection open going from the end user. It's to the CDN, we call it the edge pop, if you will, to the CDN shield pop, to the customer's origin. All of these can have persistent connections, and they're kept alive with little messages going back and forth. And what that does is, if you're coming in to send a file, you've already got a connection open ready to go, versus having to do that setup of the connection, send the data, and tear down the connection. A lot of the optimizations kind of, again, they build on one another to go through all of this. There's another whole class of techniques that happen. Large windows, you got fast retransmit, fine-grained retransmission timeouts, and fast recovery. Doing the slide in the animation was a little difficult for that, so I guess I'd like you guys to think about it's a little bit more of what's going on at the packet level and how to optimize that kind of traffic. So I showed it by merging cars and coming up with an algorithm to merge cars appropriately. But anybody who's flown, I don't know, like Southwest Airlines versus United, you see the different approaches they take for kind of hoarding us all and boarding us all into the plane. There's different techniques that can be planned out, tested, and adjusted. And United's got their approach, and Southwest is theirs. CDN vendors are doing these kind of techniques as well for the first mile, the middle mile, and the last mile. Because mobile is such a large part of the viewing of the audience of users around the world, CDNs and other vendors are really pushing into the mobile network operator space. They can do this a couple of different ways, just by partnering with the network operators, but they can also partner with the vendors who sell to the network operators, so they can get their software and intelligent smarts and caching and all of that pushed in as close as possible. The mobile network operators really like this because they really have two goals. One, of course, they want to give us all the best end-user performance possible, but they're also interested in saving traffic on their RAN, their radio area networking. So in this slide, I happen to show more than dynamic acceleration. I'm not going to read it, but a mobile network operator would be interested in everything, that all different types of content techniques that can speed things up as well as reduce RAN traffic. The third one that I kind of showed right at the beginning is this dynamic encrypted content. So some banking or e-commerce customers have transactions that they want to accelerate globally, but they really can't share their certificate. But they are asking for some kind of acceleration. So CDNs can do this, most of them anyway. They don't do it at the HTTP level. It's more like a TCP or an IP connection that is being accelerated along the way. It's a lower level of acceleration. So not all of the techniques that I talked about so far will work. Some of them do, and some of them don't. It depends. And the nice thing about this kind of technique is the encryption is happening on the client, the customer's, device, and the encryption's also happening on the customer origin. So the CDN cannot see the real traffic, cannot decrypt the traffic, and therefore some of the techniques like compression and caching are not available, because it's just a bunch of noise traffic, and we're just moving it from destination using as many techniques as possible. Which leads to what I'm seeing a lot more is common architectures, where somebody will have their main application that really has no end users connected to it. So they've built out this main application, there's no end users connected to it, and they have proxy or application servers in a couple of regional locations, generally not enough for global performance. So the CDN is fronting the proxy servers or the application servers, and then the end users are connecting in everything from TCP level acceleration for applications or HTTPS for browser-based. And we're seeing this much more complex architecture coming around where customers are very interested in protecting their origin and locking down everything as much as possible. So, as part of performance and availability, DNS for 30 seconds here. The whole presentations have probably been done on DNS. If you're using a cloud-based DNS system, I mean, every link has DNS component to it. Most vendors are using an Anycast solution, which is the servers all have the same IP address, and then BGP is kind of collapsing and automatically picking the best route. It's the easiest way to kind of get this global DNS, global geolocation, GSLB, if you've heard those terms before. And CDNs will use this for geo-targeting, and it comes with the LDNS's IP address, which is a local DNS, which isn't necessarily the end user's machine IP address. So a couple of years ago, there was this extension to DNS called the eDNS client subnet, and it's a way for the LDNS to pass back the end user's network part of their address so that the CDN can use that for appropriate geo-routing. And it's really popular with like Google DNS or whatever. I mean, I'm sure a lot of people use that. If you've ever had trouble with the CDN, it might be because they don't support this technique, even though it has been available for, 3 years or something like that. In terms of performance and availability, I mean, availability and security, it's just going hand in hand nowadays. And customers are asking for a lot, so I've just got 2 slides on security just to represent what they look like. You got web application firewalls, where you hear that term or you want that as part of your solution. This is where you're looking at the data itself, looking for cross-site scripting or SQL injection or something like that. You're trying to scrub out all of the bad data before it gets to the customer origin. So that's a web application firewall. Second big area would be denial of service attack. This is where the attackers, heck, today it seems to be mostly kids with $200 extra cash are running these denial of service attacks. And that's where you got these multiple devices and servers all trying to connect and send bad packet and volumetric packets, bad formed everything that you can think of, trying to take down some hop along the way. And so CDNs are really pushing into that. It's hard to do performance and availability solution if you can't offer the data protection and can't offer a path to secure the content. So my final few slides here are just on best practices. So let's say, determine your domains. Most folks are looking at static, dynamic, encrypted content. If you break them into separate domains, you get different techniques that you guys can use. There have been some great velocity shows on static and how to take advantage of having multiple domains and what happens all along the way. But if you break things into static, dynamic, and encrypted, then you have different techniques. If you've got a global customer set, make sure that your DNS and CDN are global. Watch out for root domain as a website. There's limitations on records for the root or apex domain on DNS. Whatever your strategy is for data consistency, you will want to think through what your primary and backup origin is, even if it's just the CDN delivering just the latest content that it has. You do have to think what that strategy should be. TTL we've talked about a lot. Be aware that CDN send some extra headers, so if you're interested in any kind of performance or, I should say more logging or debugging information, there's often extra headers like the POP that the CDN delivered it from. And CDNs are fully automated, so you can almost always API a full CDN, everything from purging to different types of content requests you can make through APIs. And the last 2 slides, I'm not going to go over these, but I just want you to think that, if you're using a CDN and they got POPs around the world and you're taking advantage of this cloud infrastructure, because they're out on the edge, sometimes you need to make changes. Sometimes you need to override the web team, the marketing team. You need to do something right now. So generally a CDN can rewrite URLs that are coming in. We can redirect URLs. We can override any of the headers. We can change any of that information. We can vary the content. So if you've got a different index.html based on a cookie or a geolocation, we can send different ones. We can black and whitelist refers and geo-control. You can pass on your own custom headers. And of course, the whole strategy for availability needs to take place. And really, that's it. Kind of a whirlwind tour of dynamic consistency requirements and trade-offs, as well as CDNs, what they're actually doing to improve and do performance. So, well, is this Q&A? I didn't really ask what happens or how this happens. Do I ask for questions? Okay. So if anybody has any questions, all I see are just 4 bright lights. So you guys might have to you might have to speak up. And of course, if there aren't any questions or somebody wants to ask a question kind of with a little bit more interaction or something like that, feel free just to come up to the stage. I see somebody in back, a couple people. Yeah, I'd say just ask your question up loud or come on down, whatever works.
How are you recommending caching it? I'm not sure I understand.
Well, it is a great question, and there can be some benefits to caching dynamic content for a very short amount of time. Let's say you wanted to cache something for 5 seconds, and at the end of 5 seconds, or even 3 seconds, 2 seconds. Sometimes if you've got a really busy proxy server, let's say I was running an ISP or something like that, you could do that. But part of it is the consistency requirement you have to go back on, think on. So if your data is something that is updated only once an hour, you've got a lot of flexibility in terms of showing something that's theoretically a couple minutes out of date, right? You could set the TTL on your content to be not 0. But if you're trying to sell something that can only be sold one time, you don't want to miss out on, hey, did seat 11B already get sold? So the choice is yours. You can override or set any of your content to be a really low time to live. A CDN will honor even if it's just a second or two. But you've got to decide if the trade-off is there. If your end users can accept a little bit of that uncertainty and the consistency, you yourself will get lower origin requests, less network traffic that comes back to origin. So there are reasons to do it. Does that answer your question? I'm not sure.
Well, I'm not going to give you too hard a time, but no.
Okay, not a problem.
Personalized site for me says, Ken's on my page and, Jim and Joe on other pages, and how do I cache that at the edge? Because it really doesn't help me to cache it even for a second, because it would have to be me hitting it again on that exact pop for it to be useful. I just didn't understand.
Oh, gotcha. I think in the general case, most dynamic content is just dynamic. It's set to TTL of 0, and it just goes back to the origin, and the CDN speeds that up. If you look at a typical site, and I'm really generalizing here, but if you look at a typical site that has dynamic and static, it could be 80, 90, or percent of higher of just static content. So the part that you're trying to accelerate and give real time, give that the priority, have it always go back to origin. You're probably never going to have a problem being able to take that load. And I would say most people do not try to cache dynamic traffic unless there's a really specific reason. It's unusual to do it. Can be done, but unusual. Yeah.
So what are your recommendations for measuring the CDN's quality outside of the CDN and their logs?
Great question. There's a lot of independent testing services that you can use. I'm sure there are everything from free to more expensive commercial ones that you can run all the time. And I do recommend that you not just run it after you've purchased whatever vendor you've gone with, but in the selection process, you should do a comparison, and you should make sure that you run the comparison at the same time. I never recommend that you run one vendor for one day, and then Tuesday you run another vendor, and Wednesday you run another one. Try to run them all at the same time, the same day, so that you can get the same comparison. I'd also say, and I didn't have a slide on it, but I thought about it, is you've got to really make sure that the vendors are setting things up the same way. And one of the critical things to look at is TTL settings, especially on DNS. And so if you got two vendors and one of them has a TTL setting that is not what you're going to use in production, then you're not really testing your environment, and the two vendors are not being tested fairly against each other. So you do really have to make sure that that both vendors have a setup that's equal and doing it the same way. You also have to be a little bit I guess, somewhat wary of a testing service. You've got to look at their network reach and global map and make sure that it gets to where you want to go. So not all the testing services are in all the regions, but if you've got customers there, you need to get somebody who's got global testing in all of those locations. Does that kind of help? Okay, great. Yeah?
You said don't use root domains for websites. Can you explain why and what you do and what do you do?
Most people, I think, most sites you just kind of redirect. And so you type, acme.com, and it just automatically goes to redirects to www.acme.com. Well, the DNS part will just, the DNS will do the DNS because it's resolving these host names into IP addresses, right? Because the internet wants to work on the telephone number, not the easy to recognize domain name. The CDN could accelerate anything, but the problem is that DNS itself, you can't, for an apex or a root domain, you can't have a CNAME record in there. It'll accept this thing called an A record, but it won't really accept a CNAME, and most CDNs are going to want to give you a CNAME. So it just kind of constrains your ability to support multiple records on a non-www site. Because you typically have NS records, and I'm no DNS expert. But there's a bunch of records that you probably want to support, and you can't delegate everything to the CDN. So typically, folks are redirecting to do that. Any other questions? I got a hat on, but I can't even see with all of the lights. It looks like that might have all the questions. Again, feel free to come on up if anybody's got any questions for, a little bit more interactivity. And if I didn't answer a question completely and you didn't want to keep embarrassing me, one, I appreciate that, but two, come on up and we'll talk about it. Again, thank you all for attending. We're in booth 707.